Happy day for my dear students and my viewers. This is L. Nagarajan, working as an assistant professor in the Department of Electrical and Electronics Engineering in MIM School of Engineering, Trichy, aggregated by NAC, approved by AICT New Delhi, and affiliated to Anna University, Chennai. So today we are going to discuss about the electrodes. Okay, in the previous slides we discussed about the cell and its structures and where the electrodes are placed and what is the role of the electrodes in this biomedical instrumentation. And now we are going to discuss about what are the different types of electrodes. Okay, now we are again starting from the beginning for the from the basis of the electrodes. Okay, let us go into the topic. Right. Okay, the electrodes are three types. Okay, the electrodes are basically classified into three types. First one is microelectrode. Okay, these are used to measure the bioelectric potential near or within a single cell. These microelectrodes are used to measure the bioelectric potential near or within the single cell. Intracellular electrode. Okay, as the name implies, it is measured the electrodes of the single cell or near the cells. Next one is depth or needle electrode. Depth or needle electrode. This one, depth or needle electrode. So what is this depth or needle electrode? What is the use? Okay, these are used to measure the bioelectric potentials of highly localized extracellular region. Okay, highly localized. Okay, highly localized in the sense it is difficult to identify a single cell. Okay, so extracellular region in brain or bioelectric potentials from the specific group of muscles. Okay, so needle electrode is used to measure the biopotentials of extracellular region. Okay, extracellular region such as the brain or group of muscles. And finally coming to the surface electrode. Okay, so this surface electrode is used to measure the potentials available from the surface of the skin. Okay, surface of the skin, and are used to sense the potentials from heart, brain and nerves. Okay, heart, brain and nerves. Usually for an patient, if a doctor is suggesting, usually he will suggest this type of test. Okay, they will know go for a critical one. They will check on the surface of our body itself. Okay, so that will be comfortable for the patient as well as for the doctors. Okay, next we are going to discuss in detail about these microelectrodes. The first topic, microelectrodes. Okay, the microelectrodes are divided into metallic and non-metallic one. Okay, metallic and non-metallic one. Okay, so these microelectrodes have smaller diameter, and during intersection of the electrodes into the cell, this will not be, there should not be any damage to the cells. Okay, there should not be any damage to the cells because it is going to measure the biopotentials of a single cell. Okay, and when an microelectrode is used to measure the biopotentials of the cell, it is located inside this cell. It is located inside the cell, and the reference electrode, okay, the reference electrode is situated outside the cell. Okay, there are two electrodes will be used. One is the main electrode and another one will be the reference electrode. Usually this main electrode is placed on the cell, that is inside the cell where the biopotential is to be determined, and the reference electrode will be kept outside the cell. Okay. The size of the electrode is determined by the size of the cell. Okay, since the size of the cell is about 50 microns, okay, from 50 microns, the diameter of the tip of the microelectrode is ranging from 0.5 to 5 microns. Okay, the size of the cell will be 15 microns, 50, okay, 50 microns, whereas the electrode diameter will be 0.5 to 5 microns. Okay, it is almost 10% less than the cell. Okay, now we are going to discuss in detail about the metal microelectrode. Okay, this metal microelectrode, it is made up of tungsten, fine tungstens or stainless steel wire. Okay, with a fine point, Okay, this technique is also known as electropointing. This technique is also known as electropointing. Which technique? Measuring of a cell potential, single cell potential using this microelectrode is called as electropoint. The electropointing are coated to the micro tip, that is with an insulating material. Okay, with an insulating material to reduce the impedance. Okay, to reduce the impedance. Okay, insulating materials to reduce the impedance, and also for the safety purpose. And also for the safety purpose. And some electrolyte processing like chloriding the tips, and then developing by the photographic developers can also be performed. Okay, few electrolytic process done reducing the impedance, and the measurement of bioelectric potential require two electrodes. As I said in the previous slide, one is kept inside the cell and another one is kept at the outside. That is reference electrode. Okay, the sum of the potential, we call it as the electrode potential. Okay, what are the three electrode potentials? It is EA is the electrode, metallic electrode, that is electrolyte potentials at the microelectrode tip, and ER is the reference electrode, electrolyte potential, and EC is the variable cell membrane potential. Okay, so here is the equivalent circuit of this metallic microelectrode. Equivalent circuit of this metallic microelectrode. So as I said earlier, here you can see the different this is the that is a value between this A and B. Okay, here is the membrane and this is the electrode and this is the reference electrode. So across these 2 points A and B, we will get the biopotential. Okay. Fine. So in this equivalent circuit, we come across different parameters. This RA, okay, this RA, we call it as the resistance of the conducting wire, which is negligible, and RS, this RS, okay, RS denotes the resistance of the shaft of the microelectrode, okay, and this is also negligible. Okay, finally the equivalent circuit determines the output of the value. So what are the parameters we are going to neglect? That will be, I will be discussing now. And next one is RS. Okay, this RS denotes, as I said, the shaft resistance. And RFA, okay, RFA, and here RMA, sorry, RMA, then RWA. Okay, it is also inside this component RWA, and CWA. Okay, it is CMA. CMA constitute the impedance of the microelectrode tips. Okay, microelectrode tip. Okay, and R in. Okay, R in. Here we can find this R in. R in is nothing but Ri. Okay, so this Ri is nothing but the intracellular fluid, resistance of the intracellular fluid, and similarly we can see RMB. Okay, RMB, and RMA is also incorporated over here. So okay, and this it is nothing but the impedance of the reference electrode. This is nothing but the impedance of the reference electrode, and this is nothing but the impedance of the micro tip. Okay, this is the impedance of the measuring electrode. Okay, and so finally, if we solve this circuit, and finally we will get the simplified equivalent circuit, and it is represented over here. And this again, AB will use the value of the single micro electrode. So hope you understand. We will go to the next topic in the next video, that is the non-metallic micro electrode. Thank you.